Resting on its blocks in the dry dock, this towering primer orange steel hull commands attention. To the untrained eye, the crisp lines of the bow and the gleam of the newly applied shot primer make it look like a finished, sea-ready ship. But step inside, and that impression vanishes. The interior is a series of dark, echoing cavities of bare primer steel. No power flows through these decks, no ventilation moves the air, and there is not a single system installed to sustain a human being for even an hour at sea. To transform this empty architectural void into a functional floating city, shipbuilders must begin the most critical phase of construction: outfitting. This is the exhaustive, meticulously coordinated process of installing every mechanical, electrical, and life support system required to make the ship operate. This chart breaks down the total shipbuilding man-hours required for a modern vessel, revealing a division of labor that most wouldn't expect. 60 to 70% of the total construction hours are spent entirely on outfitting, a workload that significantly outweighs the time spent erecting the steel hull itself. Erecting the steel hull merely creates an inert container. It is the exhaustive labor of outfitting that actually builds the ship, taking raw, lifeless metal and assembling it into a fully functional organism. A modern large crude oil tanker requires over 100 kilometers of complex metallic piping to transport pressurized fuel, ballast, and seawater cooling. That is more linear meters of pipe than the entire vessel is long, stacked floor to ceiling inside the hull. To manage this immense volume, advanced shipyards use a strategy called pipe piece family manufacturing. Rather than building the plumbing system by system, they group pipes with similar physical attributes and fabricate them in highly efficient, standardized batches. Running parallel to this circulatory system is the ship's electrical nervous system. A single vessel can contain up to 5,000 kilometers of heavy multi-core cable. That is enough wire to stretch from New York to Glasgow, carrying power and data to the deepest, most isolated corners of the ship. This diagram shows a cross-section of a steel bulkhead fitted with a cable transit. When wires must cross watertight compartments, they pass through these cast steel frames. Black rubber compression glands seal tightly around each cable, physically blocking fire and water from spreading. Before a single pump can be started or a light switched on, this sprawling, three-dimensional architecture of veins and nerves must be perfectly mapped to distribute fluids and power throughout the entire hull. Deep within the lowest decks, the machinery space receives the most formidable component of the build. A modern two-stroke propulsion engine can weigh up to 2,500 tons and stand 4 stories high. Too large for any doorway, it is lowered by a massive gantry crane straight down through a vertical casing deliberately left open. This diagram illustrates the critical physical process known as shaft alignment. Once landed, the engine's crankshaft, the intermediate shafts, and the propeller shaft must be adjusted until they share a single, perfectly straight common axis. Despite weighing thousands of tons, engineers use digital lasers to verify this alignment down to hundreds of a millimeter, a mathematical tolerance finer than the diameter of a human hair. If that axis is misaligned by even a fraction, the consequences are disastrous. The spinning shaft will introduce severe vibration, causing rapid metal fatigue, extreme bearing wear, and ultimately catastrophic failure. Achieving this singular, microscopic physical connection is the absolute requirement for safely translating massive mechanical combustion into forward oceanic movement. While the machinery space roars with raw mechanical power, the forward accommodation block is built for human survival. Shipwrights thread extensive HVAC ducts through the decks and install thick mineral wool insulation, creating safe, temperature-controlled fire zones for the crew. Instead of building individual rooms plate by plate, modern shipyards lift fully prefabricated, factory-built cabin modules and drop them directly into the hull. Completing this work off-site and plugging it into the ship's systems improves the shipyard's outfitting productivity by over 50%. High above these cabins, on the navigation bridge, all of the vessel's distinct networks finally converge into the Integrated Automation System, or IAS. This is the digital brain of the vessel. The IAS unifies these vastly complex systems into a single secure architecture. From one touchscreen console, a watchkeeper can monitor real-time data, balancing ballast water levels, checking engine bearing temperatures, and managing fire alarms. The integration of modular habitability and centralized digital control elevates an industrial steel structure into a self-sustaining, highly intelligent human outpost. The process culminates in the integration phase. Independent trades hand over their completed work. The miles of piping are pressurized and flushed, the electrical circuits are energized, and the diesel generators are started up for the very first time. The dark void finally awakens. Amber light glows warmly from the accommodation portholes. Fluids rush steadily through the newly installed vanes, and high above the deck, the radar antenna spins, testing its sweep against the darkening sky. Internally, the ship is now a complete, intelligent system. But despite this mechanical strength, its outer skin is still nothing more than exposed, raw steel. If this unarmored hull slips into salt water as it is, the aggressive marine environment of salt, oxygen, and ceaseless physical abrasion will ruthlessly attack the metal, rapidly corroding and destroying its structural integrity. Before this vessel can meet the ocean, it needs a shield. Next time, we explore the intense industrial world of marine surface treatment, where high-pressure abrasive blasting and specialized epoxy coatings are used to armor the raw steel shell for the battles ahead.